today's integral of the day, December 24th, is the integral from 0 to 1 of ln of 1 plus x all over 1 plus x squared. So the first thing that we notice is that there's a 1 plus x squared term, and that immediately tells us to use tangent for u substitution. So let's first figure that out. So let's set x is equal to tan t, and you'll see y in just a second. So dx is equal to secant squared t dt. So let's write our new integral with this substituted in. So 0, our new bound will be 0 equals tan t. That's tan of 0. 1 equals tan t. So tan of pi over 4 equals 1. So those are our new bounds. Then we plug in the value of x for tangent whenever we see it. So ln of 1 plus tan t all over 1 plus tan squared t dt. Or, well, now we have to multiply by the correcting factor, which is secant squared t dt. So times secant squared t dt. So there's a trig identity that says that 1 plus tan squared of t is equal to secant squared of t. And this is from the Pythagorean identity. So 1 plus tan squared of t is equal to secant squared of t. So we can just simply cancel these two out. So our new integral expression is simply just, I'll write it over here. So it's now going to be 0 to pi over 4 of ln of 1 plus tan of t. We can rewrite tan t to be sine t over cosine t. And we can make a common denominator. dt. And there's a logarithm rule that states that log of a over b is equal to log of a minus b. So we can utilize that here to create two separate integrals. So we get ln of cosine t plus sine t dt minus 0 to pi over 4 of ln of cosine t dt. So we have two separate integrals. Let's first work on this integral. So ln of cosine t plus sine t. Erase this. So there's a pretty bulky term, cosine t plus sine t. Luckily, there's an identity that states that cosine, write this a little bigger, that states that cosine t plus sine t is equal to root 2 times cosine times t minus pi over 4. So cosine of the quantity t minus pi over 4. And, well, you can work this out algebraically, which I'm going to do, but you can also reason this graphically just to prove to yourself why this is. So let's draw a graph. So this would be pi over 4. Sorry, let's denote to be pi over 2, that to be pi over 2 actually. Pi over 2 negative pi. So sine of x is going to come up like this. Cosine x is going to start at 1. It's going to be 1. So it's going to go like so blue is cosine t, red is sine t. And we're interested in finding cosine t plus sine t. So we get the value of cosine and add the value of sine. So right here we have a value around here. Here at pi over 4, we have the maximum value, which is in fact root 2. And here, let's sum it up. So here it becomes 0. So you have this value. Here this is 0. So we have value down here. So here we have the value down here. So the sine, and then it will eventually go back up. So we have a sinusoidal function that kind of resembles a cosine or sine curve. That also has a period of 2 pi. It should have a period of 2 pi because these two have periods of 2 pi. And its amplitude is root 2. And just to show how this works, this value, this curve is shifted it's shifted pi over 4 to the right of the regular cosine curve. And here we have the same pi over 4 shift to the right. Just to prove to you intuitively why this kind of works graphically. But we can also use another property. We can also use the fact that this is a cosine and we're subtracting 2 terms here. So we can use a cosine subtraction identity. So here we have root 2. Let's use identity, which is cosine t times cosine pi over 4 minus sine t sine pi over 4. And immediately we note that the cosine pi over 4 here and the sine pi over 4 here, they're both 1 over root 2. So you can take the 1 over root 2 to the outside. Cosine t minus, this should be plus. Cosine t plus sine t is left. And this matches our original expression. So this identity is correct, and we can use it now. So cosine t plus sine t, let me write it real quickly. We can replace the inside of this with this. So in red, I'm just gonna do this integral. So we have 0 to pi over 4 of ln of root 2 cos t minus pi over 4. And just to be clear, we're only working on this integral for right now. We're gonna get to this in a bit. Okay. So we use another log property where if we have the logarithm of 2 things multiplied inside, we can split it up into log of a plus log of b. We can break this up into 2 separate integrals again. ln root 2 dt plus cosine 2 minus pi over 4 dt. And this is equal to, well, here we have a constant, ln of root 2. And obviously a constant, if we integrate that, that's very simple. ln of root 2 times pi over 4 minus 0. And ln of root 2, using simple log properties again, root 2 is 2 to the power of 1/2. So this becomes 1/2 ln of 2 times pi over 4. So this part becomes 1/2 times pi over 4, pi over 8 times ln of 2. So we have this part done. So we are done with this part. This part is done. We still have to work on this part. This part we still have to work on. And we still have to add this part back in. So now let's work on this and this. So what we have left is, I'll box this off here for now. We have this integral from here, and we have this integral from before. So let's add both of those together here. Let's add this one back in, sum 0 pi over 4 ln cosine t dt. And we note that these two integrals, they look very, very similar. They're the same bounds. They both have, should be an ln. Ln of cosine t d cosine t. They will have an ln of a cosine term. And this one is just phase shifted pi over 4 to the right. So what we can do is do a simple use substitution here for u is equal to t minus pi over 4. You can also mentally do this as well. You can mentally just replace the bounds and just make this into t. But I'll just show the process. So if u is equal to t minus pi over 4. So then our new bounds, I'll do this in purple. Our new bounds, 0 minus pi over 4 minus pi over 4. Pi over 4 minus pi over 4, 0. ln of cosine of u du minus 0 pi over 4 ln cosine t dt. So the integrands are the same, except the bounds are different. So the bounds here, we just do this on a number line, just to visually show you guys. So you have this function. From -4 to 0 is the first one, and from 0 to pi, from negative pi over 4 to 0 is the first one, and the next one is 0 to pi over 4. So they're the same distance away from the origin. So if this function was symmetric about the y-axis, then these two values would be equal. And are they? Well, let's find out. So let's check if ln of cosine u is even. So even functions take the form of f of x equals f of negative x. And we have ln of cosine x. So cosine x, let's first take that. Cosine x is equal to cosine of negative x. You can realize this from the unit circle. And if you just take the log of both sides, which should be okay because these two values are equal, so this works. So ln of cosine x is an even function. So it is symmetric about the x-axis. And any function, sorry, it is symmetric about the y-axis. And any function that is symmetric about the y-axis, the value from negative pi over 4 to 0 and the value from 0 to pi over 4 will always be the same. And we can understand this graphically as well. So let's try graphing this function, ln x. So our function is ln of cosine x. So here's pi over 2, here's pi over 4, here's negative pi over 2, here's negative pi over 4. So cosine itself, at 0, cosine is 1, ln of 1 is 0. So we start here. And as we increase the value of cosine x, we get to a value closer to 0. Because cosine x is from 0 to 1. As we go to pi over 2, we get closer to 0. And at pi over 2, we have 0, which is undefined for the logarithm. So the function looks something like this, with an asymptote at pi over 2. Similarly, as it goes to negative pi over 4, it'll still be positive in a value between 0 and 1, approaching 0. So it'll look similarly like this, with an asymptote at negative pi over 2. And we notice that this is symmetric around the y-axis, and this area, the area in yellow, which represents this integral, this area, is equal to this area here, which represents this integral from 0 to pi over 4 to negative pi over 4 to 0. So the key idea here is that even functions are symmetric around the y-axis. So these two values are going to be equal. So negative pi over 4 to 0 is going to be equal to 0 to pi over 4 for this specific function because it is even. So the value of this is equal to 0. Because we're taking this area, subtracting this area, and they're equal areas. So are there any other integrals that we have left to include? Well, no. So we initially had this big integral, then we split it into this integral and this integral. This integral, we split it into these two integrals, 1 and 2. And we evaluated the value of 1. So I'll label this integral 1. I'll label this integral 1. This was integral 2. And this was integral 3. This here was integral 3. Okay, down here. We found the value of integral 1 as pi over 8 ln 2. And we noted that integrals 2 and 3, they're both equal and they're subtracted. So the sum of them is equal to 0. So our answer, our final answer, is simply the value of integral 1, which is pi over 8 ln 2. That is our answer. Pi over 8 ln 2 plus c. Or not plus c, because this is not this has integral as bounds. So pi over 8 ln 2. And that's the answer to this question. So thank you guys so much for watching.